Hi, in this video I will be using a permanent magnet BLDC motor as a powerful generator. Now this BLDC motor is 250 watts and is from an electric rickshaw. Now a BLDC motor has 3 terminals and you can see that this one has 2 cables. The thicker cables contains 3 wires that are for running the BLDC motor and the thinner cable is for controlling and sensing. Since the controlling cables are not needed when using this as a generator, so I'm going to remove them, but I will still leave a little bit wire just in case if I'm going to use this motor as a motor in the future. Now the BLDC motors containing ferrite magnet are easy to rotate, but these BLDC motors use neodymium magnets that have real strong magnetic locking, which makes them really difficult to rotate with hands. So if you are planning on using them as a generator, then you must consider this as a back factor. Also, the magnetic locking is so high that it is almost impossible to give it a spin with your fingers when compared to our usual permanent magnet brushed DC motors or brushless ferrite magnet BLDC motors. The armature windings of this BLDC motor are star connected and the generated output from a BLDC motor is always alternating. Now you can see that there are 3 wires, so it is 3-phase alternating current. Now I'm going to use a multimeter to measure the voltage across any 2 terminals of this BLDC motor, since all the 3 terminals will produce same voltage because of equal number of turns for their armature winding. Now the voltage rating of this BLDC motor is 48 volts. So for that reason I am going to choose any 2 terminals for checking the voltage. Also, the hand rotation voltage is going to be very low since the rated RPM of this BLDC motor is around 3000 for 48 volts. So the maximum voltage that I can achieve through hand rotation is just 3 volts AC. Now I'm going to use a plastic rope to rotate the shaft of this BLDC motor at a little higher RPM, and let's see how much voltage I can obtain. So you can see that the maximum voltage I achieved was 14.6 volts with the rope, and the voltage was open circuit, meaning negligible current. Now for calculating the current generated by this BLDC motor when used as a generator, I will have to use a bridge rectifier. Now since I don't have a 3-phase bridge rectifier, so I'm going to simply use a single phase bridge rectifier and then multiply that ampere with 3 for 3 phases. So for connecting the bridge rectifier to the BLDC motor, I will choose any 2 wires of the BLDC motor and connect them to the AC marked terminals on the bridge rectifier. This method is going to give me current for single phase. So the maximum hand rotation amp reading was 0.84 amperes, which is 840 milliamperes. Now I will conduct the same test with rope rotation. So you can see that the output current measurement gives an improved reading with the rope because it is easier to rotate the shaft this way. So the maximum current spike that I could achieve was 3.89 amperes, which is almost 4 amperes, since it's just a roundabout calculation. Now let's do some tests with practical loads. Like this one is a 12 volts motorbike bulb that I'm going to use as a load for this BLDC generator. Now since this one is a resistive load, so I don't need to use a bridge rectifier, or even if I use it, it won't matter. You can see the bulb can glow brightly with this. Now here what I have is an incandescent 12 volts 55 watts bulb, but its glass is broken and still the filament is still connected between the terminals, so it will glow for some time until the filament gets oxidized and burns up. So I'm going to test it with this generator. So as you can see that the bulb is glowing brightly and there is smoke indicating that the filament is getting oxidized. Oxidation can be confirmed by a white coating on the terminals of the filament and terminals holding the filament. So guys, now I'm going to use a 12 volts to 120 volts transformer to step up the generated output voltage of the BLDC motor. Now the transformer is also the single phase transformer, so I'm going to connect any two terminals from the BLDC motor to the thick winding, which is the primary winding in this case of the transformer, and to the secondary winding, which is the high voltage winding 120 volt. I will be connecting a holder. Now you can see this is an LED bulb, 3 watts, and since the power rating of this bulb is really low, 3 watts, so I can easily light up with just simple hand rotation. Now for some better output, I'm going to use this thread to light up the bulb. You can see that the bulb is glowing much brighter and more continuous. Now I'm going to replace the LED bulb with a CFL. Now the CFL was 15 watts, but this is a 100 watt incandescent bulb. That is the final power output. So as you can see that the bulb is glowing but not as bright as when it is connected to our home socket, since the transformer is only 120 watts.